This is a simple watch, but did you know the time it's showing right now is wrong? Exactly wrong. Because if at this very moment you check the watch of an astronaut sitting on the International Space Station, the time there would be different. And the craziest part is that astronaut literally travels into the future every time they return to Earth from space. Yes, time machines are real, and we're actually using them every single day. Now I know what you're thinking, what is this guy talking about? But this isn't science fiction, guys. This is pure science. And today, I'm going to show you how time travel isn't just something in Hollywood movies, but actually a part of our reality. So let's start in the year 1905, when a 26-year-old patent clerk who couldn't even get a job at a university completely changed our understanding of the universe. His name was Albert Einstein. In his special theory of relativity, Einstein introduced a mind-blowing idea. He said that time is not absolute, it's relative. That means time does not move at the same speed for everyone. Now, when scientists of that era heard this, they were shocked. Because since the time of Isaac Newton, it was believed that time was a constant, a universal clock, ticking at the same rate everywhere in the universe. But Einstein said, no, if you move fast, time will slow down for you. The faster you move, the slower time passes. And this is not just a theory anymore, it's a proven fact. Let me show you a real experiment that took place in 1971. Scientists Joseph Hafele and Richard Keating took 2 atomic clocks. Now, what are atomic clocks? They are so accurate that they can detect differences of even billionths of a second. So they placed one clock on Earth and put the other on a commercial flight, sending it around the world. When the clock returned, what happened? There was a difference between the 2 clocks. The clock on the plane was slightly slower than the one on Earth. The difference was just nanoseconds, but it was there. That means the clock on the plane literally time traveled a tiny bit into the future. And this wasn't just a one-time experiment. Today, it's so common that our GPS satellites have to calculate this time dilation every single day. Look, these GPS satellites orbiting in space experience time slightly faster than on Earth because they are in weaker gravity and moving at high speeds. If we didn't correct this time difference, our GPS would start giving wrong locations by up to 10 kilometers every day. So yes, time travel is real and we use it daily. Now the most interesting case is Russian cosmonaut Sergei Krikalev. This man has spent a total of 803 days in space on the International Space Station, which orbits Earth at around 27,000 kilometers per hour, according to calculations. Due to this high speed, Sergei Krikalev has traveled about 0.02 seconds into the future compared to people on Earth. Yes, just 0.02 seconds, but technically, this man is a time traveler, the most traveled human in time. Now the real question is, can we scale this time travel? Can we build a machine that can actually take us years or centuries into the future, or even into the past? Well, traveling into the future is theoretically possible and actually quite simple. You just need to travel close to the speed of light. Now what is the speed of light? 300,000 kilometers per second. At this speed, time would almost stop for you, while it continues normally for the rest of the world. Imagine you're in a spaceship traveling at 99.9% the speed of light. You travel for just 1 year, but when you return to Earth, 22 years would have passed here. If you travel at 99.99% of light speed, your 1 year would equal 70 years on Earth. And at 99.999%, 1 year for you would equal 2,236 years on Earth. This is called the time dilation effect. This is not a hypothesis, it's a mathematical certainty. It comes directly from Einstein's equations. So, theoretically, if we build a spaceship capable of reaching near light speed, we could easily travel thousands of years into the future. For you, it would feel like just a few years, but for the rest of the world, centuries would pass. But there's a problem, a very big problem. To reach light speed, you need infinite energy. Yes, infinite. The closer you get to light speed, the more your mass increases, and the more energy you need to accelerate further. Even the total energy of Earth wouldn't be enough to send a single human to light speed. So for now, it's impractical. But scientists have proposed other methods. The first is gravitational time dilation. In his general theory of relativity, Einstein revealed another mind-blowing idea. Gravity also slows down time. The stronger the gravity, the slower time moves. Have you seen the movie Interstellar by Christopher Nolan? There's a scene where they land on a planet near a black hole. The gravity there is so strong that 1 hour on that planet equals 7 years on Earth. This wasn't fiction, it was real physics. Nobel Prize-winning physicist Kip Thorne worked as a scientific advisor on the film, and all the calculations were real. So, theoretically, if you spend some time near the event horizon of a black hole and return, you would have traveled into the future. For you, just hours, but for Earth, decades or centuries. But again, the problem is that reaching a black hole, surviving near it, and coming back is currently impossible. We simply don't have the technology. The second method is wormholes. This is probably the most popular concept of time travel. Wormholes are shortcuts in space-time tunnels that connect two different points in the universe, or even two different times. Einstein's equations allow wormholes. They are mathematically possible, but do they actually exist? We don't know. And the biggest problem is that even if we could create one, we would need negative energy or exotic matter to keep it stable, something we haven't discovered yet. Some quantum effects can produce tiny amounts of negative energy, but nowhere near enough to create a stable wormhole. So for now, wormholes remain a theoretical possibility. The third method is a rotating universe. In 1949, mathematician Kurt Gödel solved Einstein's equations and discovered something crazy if the entire universe were rotating. Space-time could curve in such a way that you could travel in loops and go into the past. But the problem is, our universe isn't rotating. Observations show that it's expanding, not rotating, so that's a dead end too. Now let's talk about the trickiest part, traveling into the past. Going into the future is still theoretically clear, but going into the past creates mind-bending problems because it leads to paradoxes. The most famous is the grandfather paradox. Imagine you travel back in time and kill your grandfather when he was young. Then your father would never be born, and if your father was never born, you wouldn't exist. But if you don't exist, how did you go back in time to kill your grandfather? It's a logical contradiction, a paradox. To solve this, physicists have proposed several theories. The first is the self-consistency principle. It says the universe won't allow any action that creates a paradox. So even if you go to the past, something will always stop you from changing it. The universe keeps itself consistent. The second is the multiverse theory. It suggests that the moment you change something in the past, a new parallel universe is created. In that universe, your grandfather is dead and you were never born, but in your original universe, everything remains normal. So no paradox, just multiple realities branching out. But all of this is still speculation. We have no evidence that traveling into the past is actually possible. And famous physicist Stephen Hawking even proposed the chronology protection conjecture, suggesting that the laws of nature themselves might prevent time travel to the past. Because if it were possible, we should have already met time travelers from the future, but we haven't, so maybe it's impossible. So the question is, how close are we today to building a real time machine? Honestly, we're not even close. Our fastest spacecraft, the Parker Solar Probe, travels at about 7,000 kilometers per hour. That sounds fast, but it's only about 0.064% of the speed of light. We are still nowhere near light speed, and accessing black holes or wormholes is an entirely different level of challenge. We don't have the materials, the energy sources, or the technology. So for now, a real-time machine is a distant dream, maybe centuries away. But what fascinates me the most is that it's not theoretically impossible. The laws of physics allow it, it's just our technological limitations holding us back. In the 1800s, people thought humans could never fly, but the Wright brothers built airplanes. In the early 1900s, people thought reaching the moon was impossible, but in 1969, Neil Armstrong stepped on it. In the 1990s, people thought storing the world's information in one place was impossible, but today we have the internet. Every impossible thing eventually becomes possible. It just takes time, innovation, and the courage to think differently, because every great innovation begins as a seemingly crazy dream. Even Einstein once imagined what it would be like to ride on a beam of light, and that crazy thought experiment turned into the theory of relativity. So guys, my message to you is simple: keep questioning, keep exploring, keep dreaming, stay curious, stay human.